Eagleeye is a real-time ingestion and profiling engine for fast data. Fast data is real-time data that typically comes in from streaming, such as through IoT technologies and event-driven applications, and is analyzed quickly to make rapid business decisions. Before we jump into the coding and how to run this code, we'll first define a brief problem statement, then we'll go through the architecture, and then we'll see how we realize that architecture through code. So the problem we're trying to solve here is detecting network anomalies. Now the users of this solution could be the SOC analysts of large corporations. So SOC analysts, they monitor the network of IP addresses and users who constantly interact and communicate with each other. So the whole idea is whenever a particular IP address or a user sends some data to each other through communication, that particular request has certain source address, some destination address. It can have certain flags like whether it is a file or not, how much memory is being transmitted, and the timestamp, of course. So once this data are being sent to each other in the network, it is quite necessary to build profiles for each IP addresses and users. That is, what is their behavior look like for the past 15 minutes or past 1 hour or 1 day, and depending on that, we can run certain unsupervised or semi-supervised machine learning algorithms to figure out whether that particular IP address or user is behaving irrationally compared to the population or not. Right, so that is precisely the problem statement we are trying to solve, and the architecture to solve that problem looks like this. So on the left-hand side, we have this multiple data from multiple VM containers or network traffic, which actually comes into the system. The system comprises of components like Kafka, Flink for data engineering, scikit-learn, Spark MLlib, PyTorch for the AI engine piece, and for the storage purpose, we have Apache Pinot for OLAP and MLflow for model storage. Finally, we also need to show the data in real time, and for that we are using Apache Superset for real-time dashboarding. So the way it works is all the raw data comes directly to a Kafka topic where that data is first synced with the Apache Pinot. So there is a Kafka connector for Apache Pinot which is available, so we can configure a topic that as soon as a record is coming to that topic, that record is being ingested in the data store. So that way we don't have to worry about whether we miss any record or because Kafka is fault tolerant in that way. Now once the data reaches the Kafka topic, there is a Flink job which constantly listens to that topic for new records. And the Flink job, what it does is we can configure, let's say we want to build a profile for 1 hour, right? So hourly profile we want to create. So what Flink job is going to do is it is going to start its window at a particular time, and it is going to listen to all the new records that is coming in that topic for the next 1 hour. And once the window expires, it continuously keeps on aggregating the profiles for each of the IP addresses or users. So for example, it can calculate metrics like how many requests an IP address sent over the network, how many files it sent, what is the total size in terms of the memory, in terms of the file size it actually contributed in the network, right? So all those metrics we can actually aggregate through a Flink job. So once the profile aggregation is done, the profiles are being sent back to another Kafka topic where the profiles are getting sent on an hourly basis, right? So hour is just an example. And from that topic, those profiles get synced to Pinot data store automatically, right? So that's the piece of the data ingestion and profiling part that happens. Once the data is available in Pinot, the AI engine actually picks up the process data, and it actually runs various anomaly detection algorithms like isolation forest, k-means, one class SVM, or autoencoder. And once the model is trained, the model is versioned and preserved in MLflow, which is used as for the model storage. And the trained models are also used for scoring those profiles in real time, so that we know that in the last 1 hour which IP address behaved abnormally, right? And we can just flag them. All this process is done in streamlined manner, and once the labels of those profiles get stored into the data store, those data can be visualized in the superset dashboard. Now, for the demonstration purpose, what we did is, because of the sensitivity of the network data, we created dummy data generator just to simulate the network events. And as we are dealing with the dummy data, so there is no point of running an actual AI model. So we are just replacing the AI engine with a dummy level, and everything else remains the same, right? So we have the Kafka, which is going to ingest the dummy data in real time, and it is going to sync those data back to Pinot data store. Flink also is going to listen to the Kafka topic, which captures the raw events, and it is going to create the profiles of various IP addresses, and it is going to push back those IP addresses profiles into a Kafka topic again, and that from that topic the data is going to get synced to Pinot. Once the data comes to Pinot, we just show that data into superset visualization, right? So that is the flow of the Eagleeye project that I'm going to just show in the next few minutes. So let's look at the data, what the data looks like. So raw network event looks like this. So it has IP address, it has a event timestamp, it has certain flags like whether it is whether it is a file or not, the number of bytes containing into this request, and the state code, that is from which geolocation this particular IP address is actually generating those requests, right? And apart from that, we have the year, month, day, hour, minute, and second. So this is what the raw network event looks like. So in this demonstration, we are going to use exact same schema for the raw network event, and the Flink job is going to listen to this raw network events. It is going to wait for 15 seconds window, so that we can show the profiling also. That's why I just kept the window duration as 15 seconds. And every 15 seconds, it is just going to create profiles of the IP addresses, right, from where the raw network events has been generated, right? And the aggregated IP profile looks like the start and end time of the 15 seconds window, right? And then for which IP address we are going to create the profile, and then what is the number of bytes that IP address sent, the number of total request in that 15 seconds window, total number of files that it sent, and the threat level we're just assigning as a dummy level here, right? So which supposed to come from the machine learning model, but as we are using dummy raw data, so we're not running the exact AI models, and we are just assigning a threat level as a dummy level here. All right, so this is the setup that we are going to show. So what I'm going to do is I'm going to start the demonstration from a code perspective. So I already cloned the repository in my system, and so if I so it is up to date with the upstream that we have. And the next thing that we are going to do is we're just simply going to follow the instructions, which is already there in the README file. So if you can see that there are total 3 Docker Compose files here. So the first Docker Compose file is which contains all the 4 services as we talked. That is the Kafka, Pinot, Flink, and Superset. The second the second Docker Compose is to configure the 2 Kafka topic with 2 tables in the Pinot. We'll come to that. And the third compose file is for creating the dummy data and running or submitting the profiler, the Flink profiler job to the Flink service. So these are the three Docker Compose files, and all we have to do is we have to just build them, and we have to bring them up, and we are going to see the visualization. And once it is done, we are just going to bring them down, right? So let's follow the steps just like this. So first, what we are going to do is we are going to just build the project. So we build the services first, right? Because those are the four services that we need to bring up first. So first thing is done. Second one is the Docker Compose, which is responsible for configuring the Kafka topic for real-time ingestion with Apache Pinot. And so that is also done. And the third one is for the dummy data generator and the Flink profiler job. All right, so all the builds are done. So now we are going to bring up the service first. Okay, so let's see what is the status of those. Okay, so they are running. So let's give it probably a few seconds so that all the services are up and running, and then we can just use the OABY to visualize whether they're running fine or not. Okay, so now from the link, if we just open this link, so we can actually access the different services through the web UI. So we can see that the Kafka is up. It has two topics, the network event topic, where the raw network events are supposed to come, and IP profile topic, where the profiling, the profiled IP data is supposed to come from the Flink job, right? So Flink is going to read from this this topic, network event topic. It is going to do the profiling, and then it is going to push the output to the IP profile topic. And these two topics are supposed to be synced with the Apache Pinot, so that will come next. So we see that Apache Pinot service is also up, and let's see about the Flink. So Flink is also up and running. And if we go to superset, so superset is also going up. So the default username and password is admin, and so we sign in, and that's it. So all the services are up and running, right? So now what we see is in the Apache Pinot there are no tables. So first we have to create those two tables, which would be constantly listening to two different topics for records to ingest. So let's do that, and that is the purpose of the next Docker Compose, which is Docker Compose initialize. So that is what we are going to run next. So we run it, let's wait for 10-15 seconds, and then we can go back to the Pinot web UI, and we should see the table number of tables changed from 0 to 2. Well, so it is now 2. So if we go to the query console, we see that there are two tables that has been created. The network event table, of course there is no data because we didn't start the dummy data generator, but it has the columns like IP, is file, state code, bytes, year, right? So it is exactly the same schema that I showed you in the presentation. And once the raw event data arrives in the network event topic, it is just going to get synced into this table, right? Similarly, IP profile table also is created, and it is configured with the IP profile topic. Once the data from Flink comes here, it is just going to show up in this table as well, right? So which has the IP address, the number of requests sent, bytes sent, and then window start and window end and thread level, right? So that's it. So we have brought up all the services, we have configured the Kafka topic with the Apache Pinot tables as well. So now the last step is to start the two things. That is, that means we are going to just start this dummy data generator, and we are going to submit a job to Flink so that it constantly reads the records coming into the raw event topic, and it is going to do the profiling, and it's going to push back to the IP profile topic, right? So that's what we are going to do next, and that logic is there in the last Docker Compose file, which is Docker Compose invoke.yaml. So we're just going to run that. So we have run it, and let's see in the Apache Flink. So Apache Flink, we see that one job has been submitted just now. It had available task slot as 1, but now that task slot is occupied by this job, so it becomes 0, and running jobs is 1. So this is what is running. So we can just quickly go in the network event topic, and if we go to view messages, we see that the dummy event generator is also actually generating the events. And this is a typical event network event looks like, which has the IP address, the event stamp, event time stamp, then whether it is a file or not, right? So just the exact raw network event that we showed in the presentation. So from this topic, the Apache Flink is going to read. It is going to profile for 15 seconds, and then the output is going to be pushed to the other topic, which is IP profile topic here, right? So if we go and view messages, then we see that these are the profiles, which is actually calculated by the Flink job, and it is going to push to the Kafka, right? So if we look at the Flink job, if we just double click on that job, so we'll see this, right? So network event, right? That is the raw network event. That is the raw network Kafka topic, right? So that is actually serving as a source, right, from which the data is constantly streaming into the IP profile aggregator. So in the middle square, this is actually the Flink job, which is actually running that logic to aggregate and in an accumulator, right? And it is doing the profiling there. Once the accumulation is done, the profiles are created, and that is being sent to another Kafka topic, which is serving as IP profile sync, right? So we have a source, we have a profiler, and we have a sync, right? And in both the cases, the source and sync are just two different Kafka topics. Source being the raw event Kafka topic, and sync being the profile Kafka topic, right? So if we look at the matrix here, so we can see that there are total 249 records has been generated by the dummy event generator, which is coming into the aggregator, the same number, but it is giving output at 45. That means in that 15 seconds window, lesser number of distinct IP addresses present. That's why the number is less, and then those many profiles are being sent to the sync, and eventually we are seeing those profiles in the Kafka topic itself, right? Now, as we did in the second Docker Compose, that is, once the event arrives in those, once the record arrives in those Kafka topics, that they will be automatically synced into the PinoDB. And so let's run something here. So now we see the data here, right? So it is constantly just syncing all the records which is coming into a Kafka topic into the tables. So if we just run a count, so every time we run, we should see it is changing, right? So we see 387. If we run it again, 391, 394, 397, 398, 3. So this is what is happening. And similarly for the IP profile table also, the profiles which are created by the Flink job, which is also getting synced here, right? So now everything is fine. We got the profiles here, and we have a threat level. So it is the dummy level that we just talked about, because we are not running a real machine learning model here. So the next step is so far what we did is dummy event network event data is coming to a Kafka topic, which is a network event topic, right? from which the data automatically gets synced to the network event table. This is where it goes, and also that topic is serving as a source for the Flink job, right, which is constantly getting the records and processing it, and after the expiry of 15 seconds time window, it is just pushing those profiles to another Kafka topic, right? And the other Kafka topic is nothing but IP profile topic, right, where we are getting the IP profiles, from which the data again goes back to Pinot into IP profile table itself, right? So now the next thing would be to just visualize this data into a nice dashboard, right? So first what we are going to do is we are going to add a database. So Superset has support for integration for any of the databases that we can think of, which supports SQL Alchemy. So here from the dropdown we can choose Apache Pinot, and the URI that we are going to use is something that I already posted here. So we'll just copy this and we're going to paste it here. So the connection looks good. Then we are going to connect. So we have connected. The next thing is we are not going to build the data in a dashboard from scratch. So we already have the JSON, something that I have already put in the repository. So we can go to settings, we go to import dashboard, we go to choose file, and then we are going to go to this threat hunt dashboard, which is there in the repository, and we upload. So we uploaded the dashboard, and once we open, this is what the dashboard looks like. We can set a auto interval for 10 seconds. That is, every 10 seconds it is going to refresh the dashboard, right? So far 703 network events have been generated. Per second, it is around 4 requests that is being exchanged in the network. And then total files sent over the network is 231 so far. Number of files exchanged per second is 1. These are the raw event that it looks like. And this is the geographic distribution, right? From California, 64 requests has been sent, from Texas, 293, and so on, right? Now, if we look at the other tab, that is the aggregated network data. So far 131 profiles has been created, right? And this is a typical IP profile looks like. So this is the window start, window end, and all the details about it. Now this is interesting. That is every every 15 seconds we are actually building those profiles, right? And here if we see that it actually just aggregates the data that is in the past 1 minute, right? How many IP addresses we identified as low threat, medium threat, and high threat. So this is just a distribution of it, right? So this is it. So this is a semi real-time dashboard that you can see. It is just getting refreshed on its own, where we can actually set the refresh interval, and that's what we are seeing. So profiles are getting created 15 seconds, so that's why it is not that fast. But in case of raw network events, so every time it refreshes, we should see new numbers here, right? So this is it. So this is the framework we just described, which I started with. That is this one, right? So we actually demonstrated the Kafka, the Flink, the Pinot, and the real-time dashboard superset. All right. Thank you.